Hello students, welcome to my channel. In this video, I will show one problem and also its solution from the chemistry chapter atomic structure. So let's start. First, let us read the problem very carefully. What the problem said: what would be the wavelength in angstrom unit of emission spectrum when the electron jumps from the level n equal to 2 to the ground state of He plus, and the values of the Planck constant, the mass of electron, and the charge of electron are provided. Okay. In this type of problem, we can directly use the Rydberg equation. The Rydberg equation is 1 by lambda equal to Rz square into 1 by n1 square minus 1 by n2 square. I have derived this expression in my last video. If you are interested, you can go through that video as well. Anyway, let's solve the problem. If we want to use this expression for solving the problem, then we need to know the value of R. But in the given problem, the value of R is not provided. If you remember the value, that is the experimental value of R is 1096.77 centimeter inverse in CGS unit, you can use that value. Otherwise, what you can do, we can change this expression to this basic expression. Why? Because the R is actually 2 pi square m e to the power 4 by Ch cube, where m is the mass of the electron, E is the charge of the electron, C is the velocity of light, and H is the Planck constant. We already know all these values because these values are already provided, and the value of C is 3 into 10 to the power 10 centimeter per second in the CGS unit. Now the problem is, what will be the value of N1 and N2? Let's check the problem again. It is said the electron jumps from the level n equal to 2 to the ground state of He plus. The ground state of He plus means the orbit will be the first orbit. Okay. So what we will do, we will put the value of N1 as 1 and N2 as 2. Okay. So let's put all these values. Here 3.14 is the phi value, and it is the mass of the electron, it is the charge of the electron, it is the velocity of light, and it is the Planck constant, and 2 is the atomic number of helium, that is the Z value of helium is 2. And as I said, N1 will be 1 and N2 will be 2. If we equate this expression, 1 by lambda will comes as 331.33 into 10 to the power 3 centimeter inverse. But we need to know the value of lambda. So we have to take the reciprocal of this value, and this will give the value of lambda, and it will comes as 3.0181 into 10 to the power minus 6 centimeter. Okay, this is the wavelength of the emitted radiation in centimeter unit, but in the problem it is asked to calculate it in angstrom unit. So what we will do, we will convert this value into the angstrom unit, and this will give the value 301.81 angstrom, as 1 angstrom equal to 10 to the power minus 8 centimeter. Okay, I hope you understood what I have discussed in this video. If you have any problem, then you can ask in the comment box. I will try to answer those questions. Okay, thank you all for watching my videos.